Ahmed, you're able to see my screen?
Yes, doctor.
Now the idea is that I'm unable to hear you. Hello,
Hello, doctor. How are you?
should we increase the volume? Shani, are you hearing me?
Yes, I can hear you.
Okay, I think that the problem is from my side. I'm unable to hear you, so maybe I should check the audio setting.
Hello. Maybe you should. Explain.
I'm hearing you now.
Oh, okay.
Okay, perfect. So, how's the situation at your home?
For me, there's no rain, but it's really dark outside. I need to open the lights to be able to see anything.
Okay, Abu Said, Sultan, and Ahmad, how's the situation? By the way, this is our classroom.
Hi, so you're at uni?
Okay, so it's just missing. Okay, Ahmad, Abu Said, and Sultan, the situation is fine at your place. Okay, yeah, that's the thing. Okay, so just let me know if you are able to see the presentation.
Yes, doctor.
Okay. So last lecture already we started with chapter 4. In the last 2 lectures, we started with chapter 4. We said that our aim in chapter 4 is to deal with higher order differential equation. So what we did is that we started by what do we mean by higher order differential equations, giving examples when we have constant options for initial value problem, when can we say that it has a weak solution or not. And then we talked about family of solutions, case of homogeneous, and in case of non-homogeneous, how can we find or what's the form of the solution. In the previous lecture, we considered homogeneous differential equations with this shape. Linear constant differential equations with constant option. For example, we considered y at the prime for y equal to 0. However, it was restricted to homogeneous one. When we say homogeneous one, it means that it's equal to 0. So this is, let's say, a second order differential equation, linear, homogeneous, and with constant option. If you still remember what was our method to solve it, we said that we use the substitution y equal mx, and our aim is to find m's, right? So we will get the auxiliary equation as m squared is 4 equals 0. This one, it has complex solutions with non-zero imaginary part. So the solution will be, the general solution, it will be cosine 2x plus d2 sine 2. Do we still remember these ones, Nas?
Yes, but doctor, will you ask us مثلا to use the delta way or use the calculator, or can we always use the calculator?
You have the right to use any method to solve the auxiliary equation, because the aim of the course is not to solve, to teach you how to solve quadratic or to solve polynomials equal to 0. The aim is about differential equations. So feel free to use any method, don't worry. Okay. Now, what's next? If we look at the title of our lecture, we already considered the homogeneous one. In this lecture, we care about undetermined coefficients, which is a method to solve the non-homogeneous part. In order to understand this lecture, all what we need is just what we mean by how we find solution of homogeneous order linear differential equation. We are learning outcome 2, and our objective is to apply the method of undetermined coefficients to solve non-homogeneous linear ordinary differential equations with constant function. We'll start first with what we mean by non-homogeneous linear ODE, and we will recall from sections 4.1 and 4.2 the general solution for it. Then we will consider our method. The lecture is relatively easy. The most important thing about it, it doesn't require any derivatives or antiderivatives. So everything, like you will be able to understand everything here without any prior knowledge. Okay, what do we mean by non-homogeneous differential equation? Again, we are considering linear ordinary differential equation with constant coefficients. Okay, if we don't have constant coefficients, the undetermined coefficients doesn't work. So this one is non-homogeneous, means that it's equal to a function, and this function is not equal to 0. If we still remember the general solution for it, first we will consider the homogeneous differential equation, and we will use 4.3 for it. The homogeneous differential equation, we will solve it, and we will find for it YC, something called YC, or we can call it YH, as you prefer. Then, after that, we have also a particular solution. This particular solution, we will find it using the method of undetermined coefficients, which will be explained it after a while. And then the general solution, it will be YC plus Y. So from this part, we only know how to find YC, which is the solution of the homogeneous one. It means that YC is solution of the differential equation when it's equal to what, miss? When it's equal to 0. Do we have any questions? Any questions so far, miss? If you are writing in the chat, I'm unable to access it right now. So in case you are unable to speak and you wrote in the chat, anyone that is able to speak, please let me know what's written or what's the question that our colleagues are asking. So again, what's our main objective? How to find Y. So our main objective is method to find YP. Again, what do we mean by YP? This is our particular solution. First of all, methods of undetermined coefficients that we will discuss today is restricted to having linear ordinary differential equation with constant coefficients, plus after the equal, we have a g of x. It's restricted for g of x to be having one of these forms. A constant. What do you mean by a constant? Who can give us an example of a constant? Like what? When we say constant, when we have equal to, equal y. So equal to a real number. This is what we mean by constant. Polynomial. What do we mean by polynomial? It means that we have x power something, and the powers are whole positive numbers. When we say whole positive numbers, it means that like 1, 2, 3, 4, we cannot have, let's say, radical x is not a polynomial. So for example, here, radical x, 1 over x, these ones not polynomials. Okay, miss? So an example of a polynomial like x squared plus 2, x cubed, x, all of these are polynomials. E power kx, e power kx, it means that example e power x, e power negative x, e power 2x, and so on. E power 3x, sine kx or cosine kx. It means that if I have equal sine x, or equal sine 3x, or equal sine x over 2, or equal cosine x over 2, it means that we can use this method. Again, miss, we did not start how to use this method. We are just saying, when can we apply our method? Now, this condition is when we have combination. We have polynomial multiplied by exponential. Like what is here? Let's change the icon. Like x cubed, let's say, e power negative 3x, or x plus 1 e power 2x, and so on. Another case when we have a polynomial multiplied by sine or cosine, like x sine x, or x squared cosine 2x. The last case is when we have exponential multiplied by sine or cosine. So these are the only things for g of x to be one of these, so that we can use undetermined coefficients. Now, what if we don't have these cases? Let's say we have linear, we have constant coefficient, but it's equal to ln x. Are we able to use undetermined coefficients? Let's look at this one. The method of undetermined coefficients, it's not applicable when g of x equal 1 over x, let's say, because it's none of the function in the previous slides. It's also not applicable for g of x equal ln x, tangent x, ex squared. What can we do in this one? This one, we will explain this one. We will discuss that in section 4.6. And we will talk about the method to solve it, which is called variation product. Okay, till now we know when can we use undetermined coefficients. But the idea is that we don't know what do we mean by undetermined coefficients. We will be dealing with something known as trial particular solution. G of x is given. We do not create G of x. It's already given. For example, if I'm telling you y double prime plus y equal 2, what's G of x? If y double prime plus y equal 2, what will be G of x? After the equal, what do we have?
Can you repeat the question?
Y double prime plus y equal 2.
2.
2, perfect. If we have y double prime plus y equal e power x, so it will be G of x.
E power of x?
E power x. Okay, so G of x is given. Our aim is to find a particular solution. The particular solution is not given, we have to find it. The good thing about the particular solution that it should look like G of x. So if we have a constant, like let's say equal 2 or equal half or equal 3, then the particular solution that we can try is yp equal a. And this a we need to find. We will learn a method how to find it. Now, if g of x is a polynomial of degree 2, of degree 1, this one polynomial of degree 1, right? Do we agree that this one is a polynomial of degree 1?
Yes.
Okay, so again, g of x, the one that we will try is polynomial of degree 1, which is general as ax plus. If you look at this third one, 3x squared minus 2, so it's a polynomial of degree 2. It means that we will take it as ax squared plus bx plus c. Again, these constants, we will learn a method how to find that. Remember, this is a trial particular solution. It doesn't mean that it will work. We will learn also when can we say that it works and when can we say that we have to modify it. When we have sine and cosine, cannot put sine alone or cosine alone. So whenever we have sine or cosine, we have to add the cosine as well. Sine for x, we will put a sine for x plus b cosine for x. So we cannot have sine alone or cosine alone. Any idea why this? So when we have particular solution, it means that it is a solution. it is a solution. It means that we are substituting it to get the left equal to the right. The sign, the derivative of the sign, it doesn't stay as sign. It becomes cosine. So we should add to it as well the cosine. If we have e exponential, it's easy. All what we have to do is just to put a constant before it. Now, these ones, if we look at that, these are combination as product. Here we have polynomial times exponential. So we'll put the exponential and we'll put the polynomial. Here we have polynomial of degree 2 times exponential, so we need polynomial of degree 2 times exponential. Here we have exponential times sine square x, so we'll put the exponential, add the sine, and add the cosine, and so on. We will start step by step. We'll start when we have only one function, and we will move just to make sure that we are understanding it. Any questions about this one?
The exponential always stays the same.
The exponential, yes, as trial, as a first step, it stays the same, exactly. And the constant, it stays as well the same. Start with an example. Let me check if we can start with this one or anything 0, 1. Okay. Would you like to solve this one, or we can put an easier one? Okay, well, let's do another one because already we have here an example. So I will explain using another example. Let's put here x. First of all, is this one homogeneous? Is it homogeneous, miss?
No.
Okay. So what's g of x? Equal to x. And what's the homogeneous equation?
Y prime, y double prime minus 4y.
Okay. Homogeneous ODE is y double prime minus 4y equal to 0. The first step, identifying our g of x and identifying the homogeneous differential equation. Are we okay with it?
Yes.
Okay. This is step number 1. Step number 2, we need to solve the homogeneous equation. Y double prime minus 4y equals 0. Remember, we said y equal emx. Instead of y prime, we put m. Instead of y double prime, m square. And instead of y, we put nothing. We put just the constant before it. So y double prime becomes m square. And this one, minus 4 equal to 0. Do we agree?
Yes.
Okay. M square minus 4 equal to 0. This means that m equal plus or minus 0. Guys, let me check. Okay. Noor, Ismail, Abu Zaid, Sultan, Dalshad, Amr, are we okay, miss?
Yes.
Yes.
Okay, guys, if you have a question, just stop me. Okay, we got m equal plus or minus e, plus or minus 2. This is the case when we have distinct real solution. So y is equal, but I will write here yh. Either we write yh or yc, because we are finding the solution of the homogeneous and not the non-homogeneous. So this is the non-homogeneous equation. Let's call it as e. Y equals c1 e power 2x plus c2 e power negative 2x. Any questions so far, miss? This one is from the last lecture. Now, step number 3, find the particular solution. Can we move to another slide, miss, and continue the question?
Yes.
Okay. Now, Step number 3, particular solution. Why? Again, g of x is equal to what, miss? G of x equal to x.
X.
This one is polynomial of which degree?
First degree.
First degree. Perfect. So what will be a trial particular solution? Yp is equal ax plus b. Now, how do we know that our trial particular solution is accepted or not accepted? This is Yp. Compare it to Yc. Is Yp dependent on Yc? Miss, here I have constant alone. Here, do I have constant alone? I mean, and Yp, I have constant alone b. Here, do we have constant alone?
No.
Constant alone, it means like plus C3 without B2x. Do we have it?
No.
Okay, so I'm okay with the B. Independent, it's not contained in Yc. Ax, is there something? Is there an x here? Do we have an x in Yc, miss?
E to the power of 2x?
E power 2x, is it x?
No.
I need x, pure x. So do we have pure x?
No.
Do we have here, do we have in Yc a pure constant? It means that plus 2, plus 3, plus c. Or do we have something times x plus x in Yc? Okay, so it's independent. It means that this Yp is accepted. Okay? Any questions?
And
Can
then
you
for-
repeat it, miss?
Yes.
Why the AX? We did not take it.
Why what?
AX, the X or the A.
No, miss. I'm saying that here Yp, we said that this is a trial particular solution. Trial, it means that I want to check, can I accept it or reject it? Why should we accept here in our case? We have B here. Do we have a constant here alone? Do we have constant in Yc, miss? Yc, does it contain a constant alone?
No.
Okay, so it's accepted. Ax, do we have a constant? Do we have something constant times x in Yc or in Yh? We have C1 times e power 2x. It means that we don't have C1 times x. And we have C2 times e to x. We don't have C2 times x. So also we don't have it in Yh. So we are okay with it. I will give you an example when we are not okay with it, just to know the difference. But as a first step, choosing Yp as Ax plus b, are we okay with it? Are you okay with choosing Yp as Ax plus b? Why did we choose it as Ax plus b, miss? Who will remind us?
Polynomial first degree.
Perfect. G of x is a polynomial of first degree. The fourth step. The question here, I will be precise in the question. If the question is find the general solution without finding the constants, we can just write y equal yh plus yp. But if I'm asking find the general solution, means that you need to find the constants A and B. So because here we are just saying solve, it means that step number 4, we need to find A and B. Why did I write only A and B? Because in the particular solution, what do we have? A and
B.
Can I find C1 and C2? Miss, C1 and C2 is the family of solution, the parameters. And these parameters, we can only find them in case we have an initial value problem. Do we have, in our case, an initial value problem?
No.
Okay, so C1 and C2, we cannot find them in this question. Only thing we need to find is A and B. Any question? So again, let's write our equation. Y w prime minus 4y equal x. And the particular solution, trial 1 that is accepted, is ax plus b. Any questions so far, miss? Do we have any question? What's our aim, miss? Find A and B. We are saying that yt is a particular solution, right? What do you mean by solution? Let's recall the first lecture in our course. What do you mean by solution?
When you substitute the value, it will be equal.
Perfect. When we substitute it in the equation, we will get the left-hand side equal right-hand side. So what do we need to do, miss, now? Substitute in the differential equation, right, miss? So what do we need? This step. Substitute yt equal ax plus b in the differential equation y w prime minus 4y equal to x. Any questions? Okay, we have yt equal ax plus b. In the equation, we have y. Also, we have y w prime, right, miss? Don't we have y w prime, miss? Look at the equation again.
Yes.
So, can I find y w prime before finding y prime? What's the derivative of ax plus b?
A.
Perfect, A. And we need the second derivative as well. Yt w prime is equal to what?
0.
0.
To 0, because the derivative constant is 0. Okay, these ones that they are here, we will substitute them. We will substitute them. What will we get?
A minus
Let me write it in front of us and check for me what should we get.
0 minus A equal x.
Okay, 0 minus A or 0 minus 4A?
4A.
Okay, so we will get, after substituting yt w prime minus 4y equal to x, we will get 0 minus 4A minus 4y, right? Ax plus b equal to x. Do we agree, miss? Y is ax plus b, right?
Mm-hmm.
Yes.
Okay. Now we have nothing to do with differential equation. Expand this one. Negative 4ax, negative 4b equal to x. We got this one. What will be the next step? Please think about it a little bit. If you want, take notes as if you are in class. Do not just follow the slides. So again, our A, find A and B. How can you find A and B now?
You do negative 4ax equals x. Like
Mhm.
take the coefficients of it. And for
Okay.
negative 4b, there is no coefficient, so it will be equal to 0.
So what you are saying exactly that two polynomials are equal if their corresponding coefficients are equal. It means that coefficient of x, how many coefficients do we have here? We have the constant coefficient and the coefficient of x, right?
Yes.
What's the coefficient of x on the left-hand side?
Negative 4a.
And on the right-hand side, we have x only. It means that it is 1, right? So
Yes.
this one, we will compare it to this one. Now, on the left-hand side, as a constant, we have negative 4b. On the right-hand side, do we have any constant?
No.
So if no, it means that the constant is equal to what, miss?
0.
0. If we have x plus 2, it means that the constant is
2.
Okay. How many equations did we get? 2. Didn't we get 2 equations, miss?
Yes.
2 equations with how many unknowns?
2 unknowns.
Now, if we have 3 unknowns, we will get 3 equations with 3 unknowns. We will solve this one. Now, this one, usually when we get equations, the same number of equations, the same number of unknowns, we can go immediately to the calculator and solve the linear system. But here, do we really need a calculator to solve it? Isn't it clear?
It is.
Okay. So minus 4a equal 1, it means that a is equal negative 1 over 4, and negative 4b equals 0, it means that b is equal to 0. Right, miss?
Yes, miss.
Okay. Remember, yt equals ax plus b. It means that yt is equals negative 1 over x only plus 0. Right, miss?
Mhm.
So we found yt. This is step number 4, finding a and b. It means that we found yt. Any question? Now, what's the last step? If we go back to the question, solve. It doesn't mean that find only the particular solution. Find the general solution. And we said that the general solution is YH plus YP. So we found YH. Already we found YP. We found already YH already. So Y is equal YH or YC plus YP. What was YH, miss? The solution of the homogeneous one, E2x plus E negative x, and YP, we found it as negative x over 4. This one is the general solution. Of the non-homogeneous polynomial. Do we need to find C1 and C2, miss? Do we need to find C1 and C2?
No.
Okay, perfect. Do we have any questions, miss? And just to make sure that we understood, I will give you another example to do it alone. But just let's go briefly on this example. Here, what's our g of x? What's our g of x, miss?
2x squared minus 3x plus 6.
Okay. What's the form of it? Polynomial, right?
Yes.
Polynomial of which degree?
Second degree.
Second degree. So the trial particular solution, it should be what?
X squared.
X squared
minus.
plus
Ax
bx
squared plus
plus
bx
3x plus
plus
c.
What's the homogeneous equation? When we put it equal to 0, right, miss? This is our homogeneous equation, equal to 0. How do we solve it? Using the auxiliary equation, right, miss? Right? Auxiliary
Yes.
equation of it is m squared minus 4m plus 4m minus 2. We got two real solutions. It means that this is YH, or we call it YC. And the particular solution, you told me that we will write it in this way. If you look, why is it accepted? Here we don't have, in YC, we don't have a constant alone. We don't have also x alone or x squared alone. So this one is accepted. Okay, miss? And then how do we find A, B, and C? Where should we substitute? Where should we substitute, miss?
In the original equation.
Perfect. So we need to find y prime, y double prime. And here, how many equations we are expecting to have? How many variables do we have? Three. So how many
three.
equations?
3.
3. Okay. What do we need to compare here? The coefficients of x squared, the coefficient of x, and the constant. We will get 3 equations with 3 unknowns. Solving it using the calculator, we will get the values of A, B, and C. Miss, here we are discussing this question. I'm not solving it. We explained it in the first one. Here we are discussing it. What we will do, the next step is that I will give you an example when the trial, or what do you prefer, when the trial is not accepted or
Not accepted.
not accepted. But, so I will give an example when it's not accepted, and then I will give you an example, some examples to do the general solution. So let's put this one. Y double prime minus y equal to e power x, 3e power x. Okay, this one. So this one we want to solve it. The question is, oh, let's think about it. I will give you a few minutes to think about it, to divide it. What's your homogeneous equation? So first, put your homogeneous equation and then put your g of x. What's our g of x, miss?
3e to power of x.
Perfect. Okay. So this is number 1, 3e power x. And what's the homogeneous equation?
Y double prime minus y
Okay.
equals 0.
Solve the homogeneous differential equation now. We need to solve the homogeneous differential equation. Again, y equal e per mx, auxiliary equation x squared minus 1 equals 0. That means that m equal plus or minus 1, right? Right, miss?
Yes.
What will be YH or YC? C1EX plus C2E minus X. We will put it in a box. Any questions so far?
No.
Okay. If you want to take some notes, please take them. I will share the annotation hopefully at the end of the lecture. If you want to take notes, please take that. Should I move to the next slide?
Yes.
I will write both of them. First, the trial YP. YP is dependent on G of X. G of X is 3X. So YP exponential times constant. Do we agree? From where did you bring this one? Let's go back to our table. When we have exponential, we will write it as the same form, constant times the exponential. Are we okay with it, miss? This one. Okay. Now, YH, what was it? C1 EX plus C2 E negative X, right, miss? Right?
Yes.
Okay. Let's check if there is a dependence. What do we have here? Constant times EX,
Yes.
right?
Yes.
And here, what do we have? Constant times
C1.
EX, right?
Yes.
So what can we say here? Dependent or independent?
Depend.
Dependent. This is what we mean by dependent. Okay. It is dependent. What do we mean? Our aim, remove dependency in YP. How can we remove dependency? Do you still remember when we got double rules? How did we remove the dependency?
Multiplied by X.
Perfect. So multiply by X. Please write this note, miss. I will wait a couple of minutes so that you finish writing. Okay. We need to multiply by X, right?
Yes.
YP equals A e power X. Multiply it by X. What will we get? YP equals AX EX, right? Right? We multiply by X, right?
Yes.
Okay. What was YH? C1 EX plus C2 E negative X. Here we have XEX. Do we have here? Do we have in YH XEX?
No.
Do we have in? Okay, so what can you say about this one? Independent. Is it accepted?
Yes.
Okay, perfect. So what's our YP, the one that is accepted? No. In 4, if we want to find A, we will substitute. And if we don't want to find A, I will let you know in the exam, Y will be YH plus YP, which is C1EX plus 2E negative X, plus the particular solution, which is AX EX. Now, how do we know that? I will ask you to find A or not. If I'm just saying solve like this question, it means that find A. If I'm telling you without finding the options, it means that keep it in this way. Most of the time, if we have lots of options, I will ask you do not find the options. Is it okay, miss? Are you okay with it?
Yes.
Oh. Please, if you want to take your notes, take them. I will put an example on the board. So we solved something in exponential, we solved something in polynomials. Let's try to solve something in cosine. And I will give you time to solve it and check after each step. Any questions before writing our next question?
But can you go back to the
Yes, sure.
cosine rule? Because I didn't really write it.
Yes. Okay. So let's write the question and then we'll go back to it. Okay.
Tamam.
So let's write this example. I will go back. Y double prime plus y plus 4y equal 3 sine. Write this question and I will move to the trial solutions. Yes.
Miss, can you go to slide 21, please?
Yes, sure. Okay, I will show just first slide 10. We want to use now this one. You can take a screenshot so that I can move to slide 21.
All right, just 1 second.
Can you move now to slide 21? Done?
Yes.
What's your question?
Sorry, 20.
22 you want or 21?
20, sorry.
22.
Okay, Miss, thank you.
So the first step is identify your homogeneous equation and identify your G of that. Please start with it. Would you like to assign you groups to solve this one? Let me just check. How many do we have here? I see. Okay, automatically. I will assign you groups to solve it, and then we will meet again after 5 minutes to check what we discussed. Why aren't you in any of the groups? Did you join recently?
It kicked me out as soon as I joined. As soon as you started the breakout session.
It's okay. You can start doing it alone.
Okay. Can you just show the question again?
Let me check if I can add you to one of the groups. Yes, I will share again the screen.
Just on. I meant the predicted.
You're able to see the screen, Mas?
Yes, I can see the screen.
Both in the predicting.
Okay. I will close the groups in 1 minute to check the discussion. Let's go back. Okay, so room 1, where did we reach, Miss? Who were in room 1?
I was in room 1.
Okay.
I reached
So,
YH.
yeah, what's YH? Y double prime is for Y equal to 0, and G of X is
3 sin x.
3 sin. The next step is solve H. Who solved H? Which room solved H?
We solved it in room 1.
Yes.
So Y double prime plus 4Y equal to 0. And
Y,
square. Yeah, Y
yes.
equal EMX. So M squared plus 4 equals 0. MP plus or minus 2I.
2y.
YH is
C1 cosine 2x plus C2 sine 2x.
so we put in a box because this one we need to use it to determine our YP or to check our YP trial YP is X. This slide are all of us okay with it? It means that solving the homogeneous differential equation and identifying our G of X. Are we okay with it, Miss? Okay. The next step. Which group would like to share with us the next step? Group 2. G of X is 3 sine YP. The trial one, we have sines. Remember when we have sine, we keep the angle as it is. And when we have sine, what should we add also? Cosine. What's the angle here? We will copy it.
X.
We have sine 2x. We will write sine 2x. If you have sine 3x, we will write sine 3x. And here we will put A, and here we will put B. Is it okay, Miss? Are
What
you
about the
okay?
3, doctor?
Yes, Miss.
Do we multiply 3 by A and B? Or
No,
just
3
leave
is
it?
a constant. 3 is a constant. Whether you have sine only or negative 100 before it or 2 or whatever, any constant, you keep it as constant.
No.
So constant, we write instead of it constant. Unless we want to remove the dependency. Is it okay, Miss?
Miss, can you go to the previous slide? Here, if how do you get square root of -4?
M squared plus 4 equals 0. It
Yeah.
means that M squared equals -4. It means that M squared equal we included the imaginary number I, which is I squared equal -1.
Okay.
I squared is equal -1. This is the imaginary one.
And for y, is it always e to the power mx?
Yes, always we start it as e power mx. Now you will tell me how from e power mx we got sine and cosine, right? When the m is real, it stays as e. When the m is imaginary, according to Euler equation, you will get cosine and sine. So if you still remember, I don't know whether in one of your electric circuits classes, you use e power by x equal to sine x plus sine x. Did you? Because to my knowledge, the electric engineering, they use the exponential. The exponential as imaginary as well. And even the communication. And if this is the first time that you see this one, is it okay for you? Did you understand it, miss? Now, the second option, you can find it using the calculator. Are you okay with it, miss?
Okay.
Okay. Okay, so what's y? YH was C1 cosine 2x plus C2 sine 2x. We'll highlight them. And our aim now, before we accept or reject, we need to check if there is dependency or independency. What do we have here? Sine x. Do we have here sine x? Miss, remember, dependency or independency, it should be same angle. Do we have sine with the same angle in YH?
No.
Okay, so what do we say about that? Independent. Cosine x. Do we have anything here? Do we have same angle? Do we have cosine x in YH?
No.
No.
Okay, so independent. Is it accepted?
Yes.
Okay. Now, suppose in YH we have cosine x. Is it accepted? If in YH we have cosine x, is it accepted?
No.
What do we need to do? Multiply by?
Multiply by x.
X.
I will give, like, after we finish this one, I will give immediately an example when they are dependent and how we multiply by x.
Doctor, do you multiply only the cosine part or do you multiply
You
whole?
have to multiply. When we multiply, you multiply the whole y. And by the way, sometimes we need to multiply more than once. I will give also example when we have to multiply more than once.
Okay.
Now, before this step, we need to find A, and again, whenever we want to find the constants, it needs that substitute. Okay, miss? We have yt is equal a sine x plus b sine x. Remember, we will substitute it where? In y at the prime plus 4y equal 3 sine x. Right? Because it is a solution. Any questions, miss? So can we find yt at the prime before finding yt prime? Can we, miss? What's
Yes.
yt prime?
Negative a sine x.
Sine it becomes cosine, and cosine it becomes negative sine, right? And yt at the prime, it is negative a sine x minus b sine x. Do we agree?
Yes.
Okay. Now, please, miss, substitute them in the differential equation and find A and B. Let's take 2 minutes for substituting and finding A and B. Write it down, substitute, and find A and B. What do we need to write this now? YP double prime plus 4YP equal 3 sine x. YP double prime minus A sine x minus B cosine x, right? From where did you bring it? YP plus 4YP is A sine x plus B sine x equal 3 sine x. Are you okay with this step?
Yes.
Okay. Now,
For the 3 sin x, don't we need to do the A and the YP also?
for what is?
The 3 sin x, don't we need to change it to A cosine x plus B
No, you
sin x?
copy it. G of x, you copy it.
Oh, okay.
G of x always we copy it because if we changed it to A and B, we will not be able to find A and B. Okay, now expand or simplify. We will get negative A sine x plus 4A sine x, or let's do it step by step. Negative A sine x, negative B sine x plus 4A sine x plus 4B cosine x equal 3 sine x. Right? Can we simplify more? Take this sine alone and the cosine alone. Can we, miss?
Yes.
So minus A sine x plus 4A sine x is 3A sine x. And the second one is 3B cosine x equal to 3 sine x. Right, miss? Both agree that we will get this one from the red step in the slide. What's the next? How can you find A now and how can you find B?
Make sine on the side and cosine on the side.
We will compare again. Sine x here, sine x here. What's the option? 3A and here. So here we have sine x and we have cosine x. On the left hand side, we have 3A here. On the right hand side, what do we have here? 3. For cosine x, what's the option on the left hand side? Left hand side, what do we have the option of cosine x?
0.
Left. Left is this is
Left
the
cosine. 3B, yeah.
Yeah.
3b
On the right
and
hand
right.
side,
0.
0.
0. Perfect. What can we deduce now? A is equal to 1 and B is equal to 0. Right, miss? 3A equals 3 means that A equals 3 over 3, which is 1. Are you okay? Is it clear, miss?
Doctor, can you go back to slide 26?
Yes, Johnny. Questions?
No, I was just seeing the answer.
Okay. A equal 1 and B equals 0. Now, what can we deduce? YP is equal. It was A sine x, right? A sine x, it means that 1 times sine x plus 0 times sine x, right? What's the final answer now? Step number 5, YH plus YP. It means that Y equals C1 cosine 2x plus C2 sine 2x. This is YH. And YP is plus YP, it was sine x, and this will be our final answer. Any questions? Any questions, miss?
Doctor, can you go back to 27? Slide 27. Okay, now I see. Thank you.
Okay. Any questions? Can I start with this question, miss? Here, without determining the options, it means that keep the answer in terms of A and B. Please start with this question. The first step, determine your H, determine your G of X. Okay, what's our H now? Y double prime plus 9y equal to 0. And G of X cosine 3x plus 2 sine 3x. So by the way, we can have this one as negative. It can be negative, okay? So we can have negative and positive. Both will work the same because the negative is part of the constant. The first step, are you okay with it? What's the second step? H, y double prime plus 9y equal to 0. Can we put the answer immediately, miss? Who will give us the answer? What's the answer for this one?
I think it's cosine 3x and then plus C2 sine 3x.
Any questions so far, miss? The first two steps, are we okay with that? Okay. Let's look now. Now the particular solution, right? So YP, remember, G of X is the negative cosine 3x plus 2 sine 3x. So we need to find now YP. What do we have here? Cosine 3x. And what do we have? Sine 3x. If we have cosine 3x alone or sine 3x alone or combination of them, all of them, they will give us the same particular solution. A cosine the same angle plus B sine the same angle. Does it make sense, Miss? Are you okay with it?
This is only if it was the same angle.
See, if different angles don't. Let's say if I have cosine x and sine 2x, I would write A cosine x plus B sine x plus C sine 2x plus D cosine 2x. This case we will discuss it when we are talking about the superposition. Okay, Miss? So if same angle, we write it. Now write again your YH. What's your YH? C1 sine 3x plus C2 sine 3x. What do we have here? Do we have the same or not?
Same, so dependent.
So what can we say about this one?
You need dependent, so you need to multiply by x.
Move dependency multiply by x, as we did in the previous one. So multiplying by x, this we will multiply x by everything in YP, which is A cosine 3x plus B sine 3x. So YP is AX cosine 3x plus BX sine 3x. Right, Miss? Right? Right again with YH. Compare them. Is it dependent?
No.
Why? Because here we don't
X.
have 4 cosine 3x alone. We have x cosine 3x and x sine 3x. So is the last one, is this one accepted?
Yes.
It's accepted. So this is our YP. What's the last step now? Do we need to find A and B here? Read the question again. Do we need to find?
No.
Okay, because we said without finding. So the last step now, y equal YH plus YP, which is C1 sine 3x plus C2 sine 3x plus AX sine 3x plus BX sine 3x, and this will be our final answer, and it is accepted. Any questions? So till now, we discussed the case when we have polynomial degree 1, polynomial degree 2. We talked about the exponential case, and when we have dependency and independency. And we talked about the trigonometric case when we have dependency and independency. Any questions before we proceed, Miss? Okay. if you still remember also in section 4.1, sections 4.1 and 4.2, we said that after the equal, we may be having different functions. Let's say, we may have, for example, already they are giving us this example. If you look at this one, g of x, it's 2 plus sine 3x. So we have constant and we have sine, they are independent. So basically here we will have how many particular solutions? We will have 2 particular solutions. One of them related to the constant and one of them is related to the sine. If you look at another example, let's say, what's that? We have y double prime minus 4y plus 4y prime plus y equal ax plus 2 minus 3 sine x. Look at this example. How many functions in g of x do we have? How many different functions do we have? How many? We have ex, we have 2, and we have negative 3 sine x. So we have ex, we have 2, and we have negative 3 sine x. Right, miss?
Yes.
Ex, we will have a first particular solution. Here we will have second particular solution, and here we will have third particular solution. Ex means that we are having ax. Do we agree?
Yes.
2, it means that we are having a constant. I use a here. Do I use it again?
No.
Do we use the same constant?
No.
Okay. Minus 3 sine x, it is sine x and cosine x. So we will use a new constant, c sine x plus d cosine x. We don't use the same constants. So here we have 3 particular solutions. Then what's the next step? Y, it will be YH plus YP1 plus YP2 plus YP3. We add them up. Because of that, we changed the options that we have.
We don't need to check for dependencies.
Yeah, we will check for dependency as well. But here they are dependent. We will find YH. YH is P1, P2x. Y equal, it will be m squared minus 2 minus 4m plus, okay, let's just change it a little bit. I will put here 4 so that it will be easier to deal with. Y equals C1 E2x plus C2x E2x. So this one, independent, and independent. Okay, miss? I will give you an example to work it out alone. Let's check. Okay. Can you check this one, miss? Of x squared minus. So, what's the homogeneous part and what's g of x?
The part on the left is homogeneous, the part on the right is GX.
So this is 3 into x plus x squared minus 3. And this one, 1 to the prime minus 2 by prime plus y equals 0. Solve the homogeneous part, Miss, first. I will take the answer from you. So the auxiliary equation is m squared minus 2m plus 1 equals 0. What's YH? C1. What's YH, Miss? What are the solutions? We will get double root m1 equal m2 equal 1, right, Miss? Right?
Yes.
Okay. This one is exponential and this one, so this one is exponential and this one is polynomial of which degree? Degree 2. So here, how many particular solutions do we have? How many particular solutions should we have, Miss? One for the exponential and the other one for? The other one is for the polynomial, right, Miss? Guys, you're hearing me?
يس بس مش كمان لازم واحدة للإكسبوننت
Yes.
للنيجاتيف 3 قصدي.
X squared minus 3 is with x squared. You can take it because it's a polynomial of degree 2.
Yeah, okay.
Okay. But if I don't have x squared, yes, you're right. I should take minus 3 out. Okay. Now, step number 3, we have 3e2x and we have x squared minus 3. This one, it gives us y1 equal ae2x. Do we agree? Do we agree, Miss?
Yes.
Okay. Is it accepted? Or let's do the second one and then decide. This one, I use A. I start with
B.
bx squared plus cx plus. This one, is it accepted?
Yes.
Why? Because if we go back to YH, it is C1 dx plus C2x dx. So it is independent. And with this one, it's also independent, right? So this one is also accepted. Okay, Miss? Any question? Do we have any questions, Miss?
What is after CX?
What's after?
CX plus what is
Plus
that?
D.
Is it zero? D? Okay.
Use any letters. D.
Okay.
So now the last step, y equal YH plus YP1 plus YP2. Implies that y equals C1dx plus C2x dx plus AE2x plus bx squared plus dx plus, and this would be our final answer if we are not asked to find the coefficients. It means that find A, B, C, and D. If we want to find A, B, C, and D, we get 4 equations with 4 elements. Any questions, Miss? Do we have any questions, Miss?
Miss, can you show again how do we find YH?
Did not attend last lecture, right?
Hmm?
Did you attend last lecture?
Sorry?
Did you attend last lecture? The lecture before this lecture, I meant section 4.3.
I think so, yeah. I'm not sure.
Okay. Now, when we have, where we were, yes, y double prime minus 2y prime plus y. Instead of y double prime, we put m squared. Instead of y prime, we put m, and instead of y, we keep it with constant, they say. So m squared minus 2m plus 1 equals 0. Either you solve it using delta or factorize or using the calculator. Using the calculator, you will get m1 equal m2 equal to 1. So you will write the solution in this way. Did you remember it, miss? If not, it's okay. Let's go back to the recording. And if you have questions, send me a message on Teams, and you can pass during the office hours or book an appointment online.
Okay, miss, no problem.
Okay? Is it okay?
Yes, it's okay, no problem.
Do we have any questions so far, miss? Here, if you look at, okay, we can solve something like this one. Let me just check which examples we can solve. Okay, maybe we can solve this one. Let's think about this example. So this one is y 1, 2, 3, 4 plus y triple prime equal to 1 minus x squared being negative x. Just write the question in front of you, and I will solve it on a separate separate one. We have here y4 plus y triple prime equal 1 minus x squared e negative x. We want to solve this. Identify first your g of x and how many functions should we divide it into, and your homogeneous part. Homogeneous one is can we start with this? Okay, this is the first step. Second step, we need to solve it. So instead of y4, we'll put m4. Instead of y triple prime, we'll put m. This one is m cubed into m plus 1 equals 0. It means that m1 equal m2 equal m3 equals 0, and m4 equal negative 1. Okay. Just because I want to multiply by x twice, copy this one as x. Already as x squared, it's already solved. So let's solve it as x. Just I changed the given to x instead of x. Now, for those who missed the previous lecture about solving homogeneous differential equation, please go back to the recording and send me on Teams if you have a certain question. You can meet me tomorrow during the office hours, or you can book an appointment. We can have it online or in person in the office. Any questions? So, Miss, please, just I changed this one instead of x squared, I put it as x. So, what will be now the solution? YH is equal C1 plus C2 plus C3 plus C4 e negative x. This C1, it came from e power 0x, which is equal to 1. Can I have C1 plus C2 plus C3? What should I do? Remove the dependency, right, miss? Right?
Yes, it will be x and x squared.
And the second one,
X squared.
X squared.
X. Perfect. So this is YH. Now, step number 3, we will work with YP1 and we will work also with YP2. So YP1 YP1 is equal to what? YP1 is equal to A, right, miss? Right?
Yes.
Okay. Where's our problem? A dependent, right, miss? Dependent or not?
Yes.
Dependent. And if I multiply by X,
So I multiply by X. Okay.
It
still
will be also
dependent.
dependent.
Okay. Again. What's our problem?
Dependent.
Dependent. Okay. Dependent multiplied by X again. Right? Right, miss?
Yes.
Where's our problem? Dependent or independent? Do we have X squared?
Yes.
So dependent, what should we do, miss?
Also multiplied by X.
Is this one accepted?
Yes.
Yes.
Why? Because it is independent. So this is YP1. So if you look here, to remove the dependency, we multiplied by X how many times? 3 times. Okay, miss? Are we done? This is for what? YP1, right? What do we need now? This is YP1, and we got it from 1. Now, what do we need? We have this one, right, miss? Miss, you slept? Sleeping?
No, we're just
No, no.
writing the.
Okay,
Yes.
think about the second one now. So now we have our second minus F EF. Okay, just let me write YH again. So YH was C1 plus CX plus 3x squared plus C4 in X. Here we have minus X. We need to find y. What do we have here? Polynomial of degree 1, right? Right, miss? And here what do we
Yes.
have?
Exponential.
So let's go back to our table to check how can we handle this. Check it. We keep the same form. So we have polynomial times exponential. The particular solution will be also polynomial times exponential. Okay, miss?
Doctor, exam-wise, will this table be provided or do you have to memorize?
Oh, yes, of course not. Miss Logic, you need to use your logic. Like I have exponential, it will be exponential. It will be the same form. If it's not the same form, of course, I will provide it. But if it's the same form, why should I provide it?
Okay.
Okay, miss? So what will be the form of a polynomial of degree 1? Miss, already I used A. Should I use A again? We use A here. Do I use A again? Do we use the same symbol more than once for the same question?
No.
Okay, Bx. And we have ether. So polynomial of degree 1 times exponential, right, miss? Right? This one is, now why am I simplifying it? To check if what? If there is dependency or independency. But it was negative x. Negative x it was, or x, negative x, right, miss? So I have here negative x, I have here negative x. It was negative, look at this. Negative, right? I copied it here, possible, so okay. Any questions so far, miss? Do we have any questions? Any questions before we proceed, miss?
No, Doctor.
Sultan, Said, let me check again. Ahmad, Noor, Shamas, Dershad, Amr, Muayyad.
No, no questions.
No.
Abdullah.
For now,
No.
for now,
question.
doctor, there is no question.
No,
For now,
miss.
we still
No
have
question.
9 minutes. When will you have questions? Okay. It seems that you are happy at home. Now we need to check the dependency or the independency. Look at this one, miss. Dependent or independent? Dependent or independent, miss? Miss, is it dependent or independent?
Dependent, miss, dependent.
Dependent.
Dependent. So remove the dependency. How? Y
Multiply by x.
is equal. X multiplied by the whole one. E negative x plus B E negative x, which is bx squared E negative x plus dx E negative x. Are you okay with it, miss? Are you okay with it? Dependent or independent, miss? Do we have x E negative x in the homogeneous part?
No.
Okay. So now the last step, y equal, of course, you need to rewrite that. You don't keep it in this way. YH plus YP1 plus YP2. Any questions? Any questions? Okay. Let's go back to our main objectives and check if we covered them. So we discussed the non-homogeneous linear ODE. We talked about the methods of undetermined coefficients. We compared them and we checked how do we remove the dependency miss. We will multiply by x. And we talked about the method of superposition. To make sure that we understood the last part, let's think about this exercise. Okay, I need this exercise without the initial condition. So just y double prime plus y equal 4x plus 10 sine x. Please think about it. Determine your homogeneous one and determine your g of x. G of x is divided into how many parts, miss?
2.
Polynomial of degree 1. And sines, right? Please think about it. Do we have any questions, Miss? Any questions?
No, doctor.
Okay, Miss. Regarding homework, the homework that is on Blackboard, already I extended the deadline for it to Thursday. After this lecture, you are able now to solve it. And already I sent you an announcement for exam 2 date. The final exam is already set on PeopleSoft. Final exam date, I think it's either June 11 or June 13th. I would love to check it and send you an announcement about it after exam 2. We will have an extra session, not this Friday, hopefully on the Friday after it, April 26th. The online session, it will be Friday at 2. It will be online and we'll be solving exercises. We will not explain you material. And it will be like a revision for the exam. Any questions for today, Miss?
Best, I'd like to say that the final exam is at 11th.
It's 11th, yes.
Yes.
Because the linear algebra is on 13th, right?
Yes.
I think one of them is on 11th and one of them is on 13th.
Linear is on 13th.
Anyways, we should be done with the material. Like if we gave some solving session on Friday, we will be able maybe to keep the last session as revision only. I will share with you the annotation. The attendance, it will be downloaded for me, so no need for taking it and wasting time. Okay, Miss, enjoy the rainy weather. Stay at home and take care of yourself. And I will see you hopefully on Thursday.
Thank you, doctor. Have a nice day.
Okay, Miss, feel free to
Thank
leave
you,
the
Doctor.
meeting. I will see.
Inshallah, thank you.
Bye, Miss.